In this video, we look at the DSBSC signals, time domain waveforms, and frequency domain spectrums. In this case here, I plot cosine signals. The frequency is 1 here. I plot cosine 2 pi t plus 4. So you can see I plot from 0 to 5 seconds. We see 5 period. 1, 2, 3, 4, 5. 5 period. So frequency is 1. The maximum for the signal, that will be 2 plus 4. The minimum for the signal, that will be 4 minus 2. That will be 2 here. So that's this message. So I modulate the signal on the carrier frequency here. Let's look at what it looks like. So this is what it looks like here. You can see this is a 2 here, and this is 6. You can see the carrier waveform follow the shape of the message here. So therefore, you can see this is AEM modulation. This is a positive part, and this is a negative part. The negative envelope is a reverse, is inverse or reverse of the positive portion of here. You just flip down from positive to negative, you will get, because the symmetry of the cosine signal from the positive part to the negative part, cosine signal are symmetric. So this is the time domain waveform. What about if I just plot cosine signal? You can see here I plot 2 cosine 2 pi t. So from -2 to 2 now. So this is a cosine signal. I have 5 seconds here. And you can see this is a frequency domain. The spectrum will be 2 delta function at 1 and -1 here, and the magnitude is 1. Right? This is a Fourier transform of the message signal. After the modulation, this is what it looks like for the modulated signal. You can see here, this envelope, the message signal, that's the red. You can see the magnitude of the carrier changing with the message. Okay, and what about the frequency domain? My carrier frequency is 10. This is just for illustration purpose, not in gigahertz, because it's so hard to illustrate if I have higher frequency here. So let's look at here. In frequency domain, I should have 2 specs at 10 hertz, and the negative frequency here, -10 there, I should say 2 specs. The carrier magnitude is 1. If we use the modulation property, the magnitude should be half, because cosine signal, I have magnitude 2, so the 2 delta for the cosine signal, the message here has magnitude 1, but there is another half for the modulation property, so therefore I should have half for all the delta functions in the modulated signal here. So it's exactly here. This is half. Where is sitting at? Sitting at 10 here. So this is 11, this is 9, this is a negative part, -11 and -9. Now let's go back here. If I have 4 here, the message, if I have 4, I should say 3 delta functions in the message signal, 2 delta at 1 hertz there, and I should say 1 delta function at DC. So 3 delta functions. The magnitude of delta at DC should be 4, and then the delta function at 1 hertz and -1 hertz there, that should have the magnitude 1. Okay, so let's look at the frequency domain for this here. So this is a DC, magnitude 4 delta function. This is 1, and sitting at 1 and -1 here. And this is time domain waveform. We looked at it just a moment ago. And this is modulated signal. This is a message signal. Move up to 10 here. And this is and this spectrum move to -10. You take half because the modulation probably have half at the front. So therefore, everything is scaled by half. This is 2. This become 0.5 here. Okay. In all of this, in your lab, you're going to generate those charts yourself. You're going to look at the time domain waveforms, the message signal. You're going to plot. You're going to just draw. You can take the screenshot, but it's strongly suggested that you draw by hand because in the next exam, in exam 1, you're going to draw waveforms. And this is a message signal. You're going to draw 1 cycles, 2 cycles, things like that. And then after the modulated signal, you're going to draw this waveforms of the modulated signal. You follow the shape of this and specify by t here. So if we have specified t here from 0 to 5 seconds here. And remember how many cycles we say here for the message. Your message have 5 cycles from 0 to 5 seconds. And from the modulated signal, I also say five cycles here from 0 to 5 seconds. But this is the content for lab, and you're going to jump the wires in the datex board. There's a multipliers there, and there's scope there, and there are also spectral analyzer. You can look at the spectrum, but pay attention that in the spectrum, bear with me a second. In the spectrum, you only say the positive frequency here. You only say this portion here. You only say 3 specs if there is a DC component there for the modulated, because you cannot say negative frequency in real systems. And pay attention to the scale of your power spectral analyzer. You want to put your power spectral analyzer in the linear scale, not in dB. We want it in linear scale. So ask the TA that if you don't say there's a clean specs, 3 specs,